Hey, greetings everyone. Good morning, good afternoon, or even good evening, depending from where you are joining to this Cloud Launch and Learn session. Today we are going to talk about machine learning and frameworks and how to build the one that's actual scales. And we'll have actually a guest from engineer from AWS who's going to present his experience and how he does that. But other than that, I want to encourage everyone to put a note on the chat saying, who you are, where you are joining from. If you have any questions, put them there. Okay, so without any overdue, I want to invite our guest speaker to the studio. Hey, Nirav,
Hey everyone.
welcome to the studio. How are you?
Thanks, Alan. Thanks for inviting me. Really excited to be here.
You're welcome. Thank you for joining so early from Bay Area in San Francisco. I know that, probably majority people there are still sleeping, but you are up and running for this, session. So thank you for joining. Uh, Nirav, I know that you are a AWS engineer, right? Not the cloud engineer, but software engineer, right? Yeah, so you're
Yeah.
helping with the development. So it's most probably there are a number of cloud engineers and software developers who are going to watch this either now or later from our YouTube channel. What would be your advice if they wanna, to become software engineer in big companies some days? What would be your 2 cents before we dive into the session?
Oh yeah, I would just say that if you really like problem solving and if you really like to take on challenges which excites you,
Yeah,
that's probably the best place to start. Because at the end of the day, cloud engineers, data scientists, all the roles are trying to solve problems for companies at scale.
right.
So if that's something that excites you, then it's easier for you.
Awesome. Yeah, that's a great advice. Thank you. Thank you, Nirav. So without any overdue, let's bring the slides, right? Let's bring the sharing of the screen into the studio, and then we can get you going. All right, I see it. So here, yeah, we can see it. So I'll be in the backstage. If there's anything, I will pop up and bring the questions. But good luck, Nirav.
Thanks, Elhan. Like he mentioned, I'm a senior engineer at AWS. I currently work with the data product team, which is why I have had exposure with working with data products and ML frameworks. Um, One of the use case we solve is trying to enrich our first party data. Um, we are trying to basically build intelligence for ourselves. I work in an organization that supports revenue and sales operations. So what we really try to do is build that context for who our customers really are. So we have a version of our first party data, and then we try to source data from different third party vendors and really try to fill in the gaps of what that customer really looks like. And we do this at scale. Everything at Amazon is at scale. So we do that for about 300 plus million records. And we try to really measure what our goals are going to be based on the intelligence we have. So it's really critical in the process of in the process of our operations, where we try to sort of gain intelligence and then use it to make tangible improvements in our strategies. Um, so today, yeah, we're going to discuss cloud native machine learning frameworks for enterprise data enrichment. Um, the use case I mentioned is just one of them, but technically this sort of strategy architecture can be extended to any high scale matching algorithms where you need to use any traditional machine learning models or even extend it to use the new AI improvements in there like LLMs and stuff. So I hope it's useful for a variety of use cases for our viewers. In today's agenda, we're going to cover a few topics. We're going to discuss how the technical architecture really looks like, we are going to discuss what different strategies are being used to make sure it works for a variety of use cases. Then I'll talk about some of the challenges that we faced and then the lessons we learned from them. If you look at the history of this, we've always sort of done this. We've always tried to sort of connect different data points, different intelligence. The way we do it has changed. It used to be simple fuzzy logic based matching. And I have my notes here. I wanted to cover a few points which are not on the slide, so please excuse me. But the basic fuzzy logic matching has always been around. Um, from joining on simple names to other attributes like, oh, is it location based or is it domain based? But ML constructs like uh, matching using probabilistic scoring came much later because there was something lacking in the way we traditionally enrich the data. We usually always left something on the table because if the data is collected by different agencies or entered by hand from someone working in the sales ops, it's not usually going to follow a criteria, a pattern. So it's always going to be in their own ways. And to bring those things together, we needed a way to sort of take the overall picture, not just think about a few attributes, and think of the overall picture on how those data really belong together. Excuse me. Yeah, so in that regard, the machine learning models really helps out with feature engineering, where we can look for different aspects of why this data might be useful to us, and then sort of assign a weighted percentage to the things that matter and try to make sure those things are given more weightage while training the models. It obviously helps with robust predictions. Once you have confidence and have enough feedback about why your model is better than what you used to have before, you can be confident of the results it can produce. Um, Seamless integration of diverse data signals. Like I hinted before, it's always going to be different depending on where the data is sourced from, where it's coming from, or who sort of built that data. Um, for any given organization or an industry, the data signal that matters the most is going to be unique. For example, if it's an early stage startup, they rely a lot on the domains, and that is publicly available information, but they might not have a static address because they're a startup and they might buy new offices, they might acquire new companies, but it's a domain that's something that remains fairly common. Even if it changes, you have sources that can tell you what the redirects are going to look like. So that's why it matters more for early stage startup. But for large industries, it's the hierarchy of the company, the hierarchy of the organization. They also have mergers and acquisitions, but in the hierarchy, how it fits all together provides a much clearer picture of that data than it would for an early stage startup. So that's what I mean by diverse data signals. And obviously, um, one of the features of machine learning models is you can improve it. So once you have enough information about it, enough results generated from it, you can feed the data back. And it's a continuous loop of learning. And that's something that really helps out in the long term. The more you build on it, the better it gets. Technical architecture for that. I work in AWS, which is why we try to use native AWS services as much as we can. Um, and to be honest, it's more than enough, more than sufficient to fulfill anything that we need to do. AWS Glue um, is something that we chose because it's dynamic, it's flexible, it's serverless. It's We use a Spark-based engine um, to sort of work on large chunks of data. And for the viewers who are not aware of Spark, basically it it's like serverless MapReduce, where we take a large chunk of data and then we write operations on it. In those operations, we try to code what to us looks like the most optimal way of handling this large sum of data. It splits it into different nodes depending on the configuration that we have provided, and then works on the data, brings it back, and then comes up with the result. Um, Internally, it creates a logical map of execution, and we are at Glue 5.0 right now. Um, I think Glue 4.0 is still used widely by a lot of implementations, but in the newer versions, that logical map that it creates internally for executing the bunch of commands, it's really improved. It's so good that it can make optimizations on its own, even when it's not really there in your code. Um, those optimization can mean a difference of how large chunks of data is handled, how it's partitioned. Um, so that really helps us out. So we use that for processing most of our ETL jobs, and also like implementing once a machine learning model is built, how we uh, use it to to make inference out of it and then to scale it up. It's serverless. So that's one thing that helps out with horizontal scaling. We have a bunch of configuration options that we can use to sort of um, to really work on large chunks of data without worrying about the optimization of those resources. If we don't need that, it doesn't need to use as many nodes. So Lambda functions, Lambda are multi-purpose. They're so useful. They're so dynamic. They can be plugged into different stages of that architecture, wherever you need to perform discrete tasks. Um, so one of the things that we do is trigger ingestion glue jobs, where if we detect something, oh, we got this new data drop from a vendor, we can trigger a specific job out of it or a specific workflow out of it. Um, we also run it intermediately for other discrete operations like checking if the data is still fresh. Do we need to do something? Are there any dirty flags that we didn't compute? Are there any alarms that are going off based on the data freshness that we have determined? So stuff like that. Step functions is my personal choice for workflow management. They are really flexible in terms of the kind of services you can use along with it. There are other workflow uh, options out there like Airflow, and then I think you also have something with SageMaker that you can use. But step functions is highly dynamic in that regard, so we can safely integrate multiple services with it. S3, it's such a robust service. Um, it has matured a lot, and it's one of the foundation of how we connect our data product operations. We store our tables there in Parquet files that is used in AWS Glue. We store intermediate model files. We store all the data that we have collected from different vendors into there. It's easier for Glue catalog to read from S3 storage, and that seamless integration allows you to sort of basically read and write data at good speeds. And the bottlenecks are there sometimes, but you can work around it by making a little bit more optimizations to how you read and write. SageMaker is again an Amazon service, AWS service that allows you to build and train models. It integrates with the most popular ones, TensorFlow, PyTorch, XGBoost. And I'm from the engineering side. Uh, the data scientists can also use it for experimenting with different models. And that it's really convenient to do it directly in notebooks. But if you want to productionize it, it offers SageMaker jobs where you can really take those learnings and then build those models. Athena is something I use quite frequently. I use it over Redshift. It's a querying machine, but like it's really useful for analysis and uh, trying to figure out different data points. If something has gone wrong, it's really good for debugging, and it's really quick in the way it works with glue catalog, which again binds it all together, which has files in S3 storage. Entity resolution. I touched upon a few of these things. We use GBDT trees as our primary modeling. Our scientists, they for our use case, they basically tried to experiment with different models. This is the one they chose because the gradual sort of improvement of it as we get and train it with more data really helps make it more accurate in long run. Annotations. Human in the loop is such an important step to this because unless you have experts in domains that will give you their feedback about why something is, you will probably get a more generic picture, but that extra sort of special handling of why something needs to be can really be solved using human in the loop. And then if the experts are annotating those data sets, really capturing their industry knowledge about why certain entities are related to each other, where are they in the hierarchy, justification for it, that really helps training and retraining your models. Probabilistic matching helps out when you have, even though you have a robust model, but you have a bunch of data that you want to infer from it. And in batch inference scenarios, you want to have not just a threshold, but a bunch of thresholds. Depending on what your use case is, you want to have a bunch of thresholds where you can really clearly articulate why a record should belong together with a piece of intelligence, how much it needs to be similar to be considered a clean hit, how much different can it be before we can start bringing in other factors to sort of see, okay, it might be connected, but we want to check a few other things. And when you have those different thresholds defined, it gives you an idea about it's not always going to be a clean hit or a clean miss. There's a lot of records that lie in between. And you want to sort of cover all of them as much as you can. That obviously improves you'll always get clean hits with most of the methods you use, but it's those intermediate records that really needs this kind of approach. Feature engineering. These are some of the features that we used, but again, like depending on your use case, it might greatly differ. For us, it's what makes a company, what makes an industry. So is it their physical locations, their lat long numbers, coordinates, how they perform in the market. So basically, if there are two people having same one first party intelligence about what they think a company is, but they might slightly vary depending on where in the hierarchy they think that organization lies. So a large company like Disney can have multiple assets, multiple facets to it where you might want to sell. So depending on which organization or entity in Disney you're trying to sell, it really defines what your strategy is going to be. So different first party intelligence still needs to match in a hierarchy. And that's what that hierarchy resolution is. Firmographic signal just means data that helps define what a firm is, what an organization is, its industry, its business model, um, its domain structure, and employee count, stuff like that. It's aggregate sales, revenue numbers. Confidence scoring. I touched upon this a little bit in my previous slide, but basically, the more, excuse me, the more high scale your model becomes, um, the more sort of flexibility you need in terms of how you're going to use that model. So probabilistic scoring is one thing where you have different thresholds um, where you wanna apply your data in. But also at the same time, you need a feedback. You need to start doing DQ checks, data quality checks, of all the annotated data that you have possibly used to train your model. You can always use more. You can always have more diverse set of experts annotating the data, and that really stems from the fact that after you have done a batch inference, you're doing a bunch of data quality checks to see if what your model has done is acceptable. So you always have that. But at the same time, it always also gives you an idea about where you need improvement. So if you have those data quality assessments, you can then make slight fine tuning of your model by retraining it or slightly adjusting the thresholds or even just adjusting the post matching logic to see, oh, it falls in this range, but okay, here's something more I probably need to do to make sense of this record. Conflict resolution is super important. Like I said, if you are sourcing intelligence from external sources, you're going to have different vendors offering different pieces of data, or sometimes the same pieces of data, but slightly different variant of it, and you need to figure out what to trust, who to trust. I've mentioned historical accuracy here. That's one of the key factors. It tells you about vendor health, vendors' data health, and it tells you about how accurate they are in going back and making those adjustments if reported. Um, but at the same time, at stages, you will feel like they are equal vendors and they provide good data consistently, and you have to pick a conflict. Then you look for things like how complete is the data, given 25 dimensions of a given data. Are Does one have more over the other? Does one have better quality over the other? And you try to gauge those things and try to make a decision based on it. So this is a really important step, um, and it can obviously sometimes be like none of them are good enough, so you just pick one. But in most cases, you'll come across conflicting pieces of intelligence, and you need to trust one. Um, and again, like domain experts in these cases, they really help out a lot. If sometimes you feel like your model hasn't done a good job and it picked a record which you don't think it should have, you can always introduce overrides to it, a manual intervention. And that's pretty common in most of the machine learning architectures, where you need a last step to sort of say, hey, you've done your job. I think it's good enough, but I think this might be better. As an expert, I think it's what it is. So you implement those overrides, and then you produce results, and then those overrides can also help out as a feedback in the next loop of when that model is trained. So um, it all works out as the scale grows, but it's an important thing to have in your machine learning architecture. The last thing, business rule integration. Yeah, domain-specific knowledge is very important. A same piece of data, the same piece of intelligence that is produced by a machine learning model can mean different things to different downstream users. Um, Sometimes for a given 30 candidates for a given first party intelligence, you want to pick a candidate which is the closest match. That's your obvious one. That's your most generic use case. Sometimes you want to pick the one which has the highest revenue numbers. It might be important for someone working in sales or trying to conduct revenue operations. Sometimes you want to pick one which has a more legal um, entity match, meaning it has more complete data in terms of attributes it cares about, um, like the hierarchy and the people it's talking to on the other side. If that is something that's important, then they want to pick that candidate. So once your candidates are inferred from the batch inference, it really depends on the post-processing logic to pick which makes sense for this use case. And you can have multiple of them. You can have it produce 15 different matches for 15 different use cases, and they're all justified because it serves a business purpose. At the end of the day, we are trying to find the truth, but we're also trying to facilitate our business. So that's why it's important to have some sort of industry specific, domain specific knowledge once the data is out of the machine learning model. Diverse entity types. I touched upon early stage companies before. Startups really they don't have a digital footprint or a physical footprint, even for that matter, as much as we expect. But they have these domains which they register, which they start working on initially. So that's like a good indicator for them. Um, Large enterprises have a great coverage. They usually do. So they're probably the easiest to match. But at the same time, you wanna make sure where you're matching it, in which part of the hierarchy you're matching with, to make sure you're covering that part of the business and not like a company blanket in general. Uh, Excuse me. Geographic variations are important. A same company working in different countries can have different operations. They might not even overlap in what they do. Sometimes they do have overlaps, but then there's a small overlap, and then there's a whole chunk of thing. Gaming studios are a good example. They're usually corporates, and then there are studios which actually work on designing and building games, and then the testing locations. Um, so those are important uh, distinctions which you make, and that's why even in the feature engineering side, geographical location, lat long coordinates, addresses are super important to determine which part of the intelligence are you really targeting here. And I spoke about industry specific entities. Some industries have, like, if you go to a healthcare organization, you usually have registration numbers and stuff like that, which are pretty unique and pretty robust. So sometimes all your model needs to do is look at, do we have an industry specific registration numbers or something like similar, which I can use to improve my scoring. Even if you don't put it in your model, you want to make it as generic as possible. It can be a post-processing where you get the candidates, but candidate number 9, which is not even in the top list after ranking, is direct match with the registration number. So that's something you can pick based on the use case you're serving, obviously. Coming to engineering, how does the scale thing really works here? Like I touched upon before, serverless is really good to use in these kind of situations. It's a way to go. Horizontal scaling really helps out when you have, for example, if you're in Glue, um, you can pick the machine you want, type of machine you want to use for that uh, machine learning inference, and then You can assign a number of workers, nodes you want to have. Um, at the same time, because it's dynamic and you use that setting, you use configuration. If I'm using 5,000 of them, which is a lot, but depends on what your data looks like, it can come down all the way down to 200 if it doesn't need it. And and it can grow based on how the data is being used at that point. Sometimes some operations, even for a large chunk of data, doesn't need that many workers. Uh, but when you really have a distributed work, that's when it really kicks in and then takes the full advantage of its serverless technology. Data partitioning is super important. Like I mentioned, we use S3 a lot. So how you partition your data, it really depends on your data. But some examples of when the data was acquired can be a partition. What country the data specifically targets can be a partition. Um, what industry it is in can be a partition. Again, it depends on your use case, but basically smart partitioning technologies techniques allows you to read and write it back quickly, because then different workers can work on different sections of the data. It's not overlapping and it's not being throttled because you're sort of spreading out that distribution. Monitoring, dashboards. They're a way to go. Monitoring not just your job health, your processes health, but also like data health. Uh, we use line graphs all the time to make sure if there's a dip in the data quality, if there's a dip in vendor quality, if there's a dip in our match rate. Those are important indicators to understand. Uh, the more you track, the more you observe, the more well prepared, the better prepared you are to sort of take on uh, abnormalities that you can see there. Um, and like a lot of tools available uh, by default in AWS. We use CloudWatch extensively for that. Error handling. No architecture, ML or otherwise, is complete without figuring out a mechanism to what to do when things go wrong and how do we get back to a previous point. Um, if you have a working version, you want to have that and then try to figure out how to get a new version. Something goes wrong, you have the ability to switch back. Your data is partitioned in a way that if a new partition is corrupt for some reason, there's an easier way to switch back to the old one. Um, as much as the technicalities of building something new are interesting and really exciting, it's the last two things, monitoring and error handling, that really makes your system robust, and your operational overload just comes down if you're doing it right, and that's what really matters when you're dealing with uh, large team, large chunks of data, stuff like that. uh, Something we do, like I mentioned earlier, 300 plus million records done, processed, using the machine learning models, and then the refresh time is 4 hours, and that is really the whole end-to-end time where you have a vendor drop a new piece of intelligence. You take that, you process it, you ingest it, then you run your model on it, you generate candidates from it, then you have the logic to pick the best candidate. So doing that for all 300 million records is around 4 hours. It it can vary a lot depending on how much data we are inferring on. We don't do it on things that haven't changed. It doesn't make sense. So sometimes we just have to do it for things that have changed, things that make sense to really really process. If there's a freshness flag somewhere, you want to check periodically if a data aspect has changed, but you want to codify that part. You don't want to keep on looking out for new pieces of intelligence. You want to automate that. So for any delta, any true delta that you have calculated, um, you want to process it again. So this is like for like a full thrust of it, but usually it can be as small as 15 to 30 minutes. Business impact. For our use case, it was uh, getting a really good view of the customers. Once you get that, you unlock other pieces of other advantages like the sales team's productivity. They know what to target. They know what to do. They know where to sell. You can customize your marketing campaigns based on it, and you can really understand your customers. You can try to form a full view of it. What technologies do they use? How likely they are to use something because they use something else, and then really analyze what they can really bring to the table. Um, but like any other piece of intelligence, it only serves you really well if you have a complete picture of it. And then this is one of the examples where first party intelligence and then intelligence from around the world is merged into building something that we can have that we can go off of one and have tangible processes based off of on it. um, so yeah, analytics capabilities. If your model has been around long enough, that your results have been consistent enough, it it increases the confidence of the folks downstream using it, and they can have better understanding of uh, what their customers are, but not also to like look over the shoulder to say, oh, is this data really right, or do I need to do my own research? They can have more confidence in it. Implementation strategies, there's nothing new. For the traditional software development lifecycle approach, you have dev environments where um, you can't have production quality data there, obviously. So you create mock data. Now there are LLMs that can do that for you, so that part has become much more easier. But you test everything. You test everything. Test-based, test-driven development will never go out of fashion. Um, but you see how it performs. You can try to bombard it with scale and see how it holds up, and then you productionize it. um, Model versioning, why is it important for us to know what our model used to be? It gives you an idea about changes over time, and that might not be important once it's mature enough, but in the initial stages it really is. You want to know for something that needed an override, how is that sort of taken care of in the newer versions. So you might want to do some checks with the older versions too. So everything starting from your post-processing logic to your model versioning to your um, feature engineering, everything, as long as there's a history behind it, you can tinker around with it and then understand where you came from and then try to use that to fine-tune it further. DQ validations, I spoke about at length. Dashboards, really important. It's really important to have um, it's really important to have that understanding of not just how fresh the data we're providing, but how consistent it is from our previous iteration. You want to avoid big blips in those line graphs. You don't want to have a piece of intelligence that is crucial just getting overridden in the next time because something went wrong. So keep validating your data. That's the most important thing. CI/CD, it's it's uh, it's something a lot of people sort of know it's good. Not everyone does it right. Integration testing, different stages of deployment, blueprint deployment strategies, rollback features, stuff like that is really important. And once you have that, your operational overload comes down. And trust me, as an engineer, the operational load is something that can make your life a bit problematic. If it's not correctly handled, you don't want to be on calls all the time. Lessons learned. Um, Technical architecture decisions that we take early on really helps you out in shaping how your product is going to look like in 6 months of time. You want to design for the future. You want to build for the future. Your architecture needs to account for changes that might happen. And sometimes you don't know, and that's completely fine. But at least if your design, your architecture is done in a way that can account for it or extend it for it, that's still good enough. Um, because there are one-way doors you don't want to go through early on, and sometimes you just gotta put your foot down and say this is the way we're going, but uh, try to be as flexible as possible, and that will really help you out when it really scales up or when you have a bunch of new features and um, functionalities that you wanna take on. Human in the loop, domain expertise beats everything else. If you have domain experts and they are constantly able to annotate the data, provide feedback, that feedback is then architecturally designed to go back into the training frequently. That really helps you out in fine tuning the model for different use cases. Sometimes you want to keep it generic, like I mentioned, right? But human in the loop allows you to have different fractals of that model and really nail that use case. We spoke about data quality and change management importance. Like I said, it's really exciting to build and experiment with new things that you've built, but it's the keep running, how to keep it running efficiently is what really defines how good your product is. Operational overload is problematic when you really scale up. Future directions. I thought about this. LLMs are so useful now. It can help you annotate the data, but you also want to build it in a way that you can trust while it's annotated. Um, there are categorization, which requires nuances. Like traditional ML models are great, but there is like semantic understanding of text that you need for sometimes categorizing your data. Um, I think I think once you have understood the difference of when to use it, it really helps you out uh, with making inference on data that you collected from different sources, but to bring them all together and build intelligence out of it, in some use cases, it's really important. Now, I'll give you an example. You you're working with early stage companies, startups. You want to build good intelligence on it, and then at some point you also want to know, hey, how much are they in generative AI, or how much of their productionized operations use that in the day-to-day operations. And you collect that information from multiple public sources and then feed it to LLM, and then it can try to deduce. Maybe they are just consumers; they use outside sources, or they are pioneers. They are trying to build something that can help the industry as well. So those kind of classification, and then because it helps you to sell better to them, so it helps you bring it all together. Uh, Real-time computing is something we have started to experiment with vector databases, trying to make sure um, data is indexed and available through like open search database, so that for a given request, not at scale obviously, but for like a given request, hey, I want to see what intelligence to have for this piece of data I have. It can run through those indexes and try to get the candidates out of it, or even provides this is what I would think it matches to the most. Federated learning, you usually get data sets from different places, different accounts. It's more of technical point, but you you want to train where the data is rather than uh, pass it around to ensure that the data is all in one place. There's data sensitivity, and if you want to avoid that, this is something that can be explored. Uh, I haven't seen a good implementation of it yet, but I've heard it's something that people are exploring. Autonomous ML systems, we kind of do that already, but like how to do that in a way that um, how to do that in a way that adjusts more dynamically to changing data, feedback, uh, data patterns, like I mentioned here, that sometimes for a given vendor, a certain data drop is so diverse, so different from the other ones. You have to go back and like make sure, let me process it right first, let me ingest it right first, and make sure it's good for feeding into our model. Um, but autonomous ML systems can sort of create that loop and do that. So in that regard, it's not something that we have done or explored, but it's certainly a good future direction for it. Key takeaways: hybrid approach. One size fits all usually works when your use case is generic, but when it's not, you want to use a hybrid approach, not just in how you build your ML framework, but also how you process the results and how it's being used. So, like I mentioned, the post processing logic, that's a good example of it. Um, you want to make sure it fits the purpose. At the end of the day, we are all serving a business use case, a customer use case. So being the most right is important, but it's not as important as fulfilling the business use case. Uh, Cloud architecture, yeah, it enables scale. It everything enables scale, but this enables scale more easily um, without with a lot of out of box features. So you don't have to go around and fine tune everything. Um, so if your use case is really scale, then I would recommend try to use any cloud infrastructure out of box as much as possible. Confidence scoring threshold, it's multiple, not just one. Um, really tells you how you're processing different categories of results and how you're building intelligence out of it. And that creates trust because you're not just picking the most obvious ones, but you're also trying to kind of figuring out the not obvious ones and how that fits into the whole picture. Business impact justifies investment. It investment is something um, you'll always have to justify your use case. You'll always have to make sure that all this engineering time, data science time, setting up all this infrastructure that costs real money, has to justify what you're building out of it. If your final product is useful to not just one purpose, but it can serve multiple use cases downstream, then it can potentially help you justify why you want to build it. Um, so that's the key. You need to know how to sell your product. Thank you. I didn't hear or I didn't see the slide, but I didn't see the chat, but I didn't hear any questions during that. So let's take this dedicated time if you have any, and I'd be happy to answer.
Um, Hi Nirav, thank you for interesting session. It was pretty engaging and insights into your experience. When you deal with data, different datas and corporations, right? While trying to tackle those problems in a different way that customers can get the results that they look for. So that was really good insights into that. In terms of questions, I don't see any new questions on our chat, but there was good number of people who switched on from time to time and viewed your session, so that was going pretty well there. Other than that, I would say, for because you covered a range of topics, so if our viewers are going to watch your session later on our YouTube channel, Cloud Launch and Learn, and I invite everybody to subscribe there and be part of it. Usually, they can put some questions in the chat from time to time, but the question that they may have to you is, what type of references they can check in order to learn more about what you shared and talked about, and how they can reach back to you if they have any specific questions.
Yeah, absolutely. You can reach back to me on LinkedIn. I'm fairly active there. Um, in terms of references, I would say look at use cases where scale is the factor.
Hmm.
It's really easier to build something robust when the scale is not at play. But you have to make a lot of decisions when you have to work with large chunks of data, not just from one set of uh, one set of sources, but when there are multiple sources combining
Right,
and in a way that you have to make sense out of all those data sets in a way that it works at scale. Those kind of examples are something where you will find a lot of these patterns that I spoke about. So yeah, whenever you do your due diligence or whenever you do your research, look for that key aspect.
right. So basically, to sum it up, what I understood is that the scale and how you want to scale will make a big difference. So depending on the scope of the problem that you are trying to tackle, are you dealing with megabytes of data? We are talking about not megabytes, probably it's going to be gigabytes, or you are talking about terabytes or petabytes. That makes a big difference in scale and tools and services that you want to consider for that custom solution. And I totally agree with that. You need always calibrate your approach based on the amount of data, criticality of solution, and availability, right? If you are going to host that solution to run, what's the expected availability for the business, for the customer?
Yeah,
Definitely.
that's well summarized actually.
Yeah. Thank you very much again, Nirav, for sharing your session here, Cloud and Lunch and Learn. We hope to see you in our next sessions. And for all the awesome viewers who were with us during this session or you are going to watch after hours, please let us know your feedback. Nirav is here to respond to any questions that you may have. And have a great day. Thank you, Nirav. Thank you, everyone, for watching.
Thanks, Ilhan. Thanks, everyone.
Thank you. Bye for now.